Welcome back to school, everybody. To start off this unit, we are going to be working on Unit 9, which is Earth Systems and Cycles. Today you're going to need 5 things. You need your computer charged when you come to class. You need headphones or earbuds that are compatible with your computer, not just the ones that go in your phone. You're going to need your science notebook, a pencil or pen to write with, and then a few colored pencils, pens, or crayons. I would say about 3 to 5 different colors, any colors that you choose so long as you can tell them apart. To start Unit 9, we're going to be doing 3 cycles today. We're going to be doing the carbon-oxygen cycle, the water cycle, and the nitrogen cycle. The way we're going to be doing this is you are going to draw them out with me in your notebook, and I'm going to talk about them while you're drawing. At the end of each of those cycles, I'm going to give you a few questions to answer for your notebook. Those are considered part of your notes that will be part of your notebook check. The answers to those questions will be either in what I've drawn or in what I've said. So it is important that you listen to this video, not just watch it or skip ahead and draw. You do need to listen to what I'm saying as we're drawing instead of listening to music or watching this silently. We're going to start today with a carbon and oxygen cycle. This one should seem pretty familiar. It starts with things that we've talked about in our previous semester. So when we talk about the carbon and oxygen cycle, we are talking about oxygen gas, so O2, 2 oxygen molecules bonded together, and we're talking primarily about carbon dioxide, not just raw carbon, but carbon that's bonded to 2 oxygens, so CO2. When we go back to photosynthesis and respiration, when we talk about the carbon and oxygen cycle, these are our main 2 processes, and you've seen these before last semester. During photosynthesis, we take carbon dioxide and water, and we produce glucose, which is a sugar that we need to survive, and oxygen. So you can see carbon and oxygen right here. Photosynthesis turns carbon dioxide into oxygen. During respiration, we have the opposite process. That glucose, sugar, combines with oxygen to form carbon dioxide, water, and ATP, which is a form of energy that our body needs. So on this side, you have oxygen turning into carbon dioxide. Remember that these 2 are reverse processes. Over here, carbon becomes oxygen. Over here, oxygen, carbon dioxide. So to start off our cycle, you should draw what I have drawn here. So I've got a little picture, little diagram. We've got our atmospheric carbon dioxide and our atmospheric oxygen up here in the atmosphere where the clouds are. And then down here we've got a little house and a car, which represent people. How do people contribute carbon dioxide or oxygen? We've got our green leafy plants, our little trees right here. And then we've got our animals, and in this case they represent both animals and people. I am not concerned about your art skills. I want you to draw this diagram simply and quickly. Do not spend a lot of time doing this. What's important is what we're going to do next. Once you have this diagram drawn, we're going to start by labeling how carbon dioxide gets into the atmosphere. So there are 2 processes that contribute carbon dioxide into our atmosphere. The first process is called combustion. So when you take something and you burn it, be that wood or gasoline, you are combusting that carbon that's in those compounds and you're forming carbon dioxide. So let's say this person has a nice fire going, it's cold outside, they're burning wood, they're adding carbon to the atmosphere through combustion. We're going to label that. Same thing if they need to drive to the store, they take their car, they're burning gas in their engine, that's also combustion. So I'm going to use a red arrow to represent combustion. Combustion adds carbon dioxide to the atmosphere. Okay? Another way that carbon dioxide gets added to our atmosphere is through respiration. So when we take that glucose and oxygen and we respire, we're doing cellular respiration when we're not talking about your lungs, we're not talking about breathing, we're talking about the process that happens in your mitochondria. You are producing carbon dioxide through that, and then you do respire, you do breathe that out. Okay? So our little sheep down here, he is respiring, so he's adding carbon dioxide to the atmosphere through respiration. Something else in this picture is respiring as well. Remember, plants also respire. They do cellular respiration. They don't have lungs, they don't breathe, but they do produce carbon dioxide through cellular respiration. So we're going to label that as well. Okay? So we've got two different ways that carbon dioxide gets into our atmosphere. How do we get that carbon dioxide out of our atmosphere? It's not good for us to have a lot of carbon dioxide in there. The process that removes carbon dioxide from our atmosphere is photosynthesis. In photosynthesis, those plants take in carbon dioxide and water, and then they use the sunlight to power their reaction that makes glucose and oxygen. So we're going to take another color. So I used red for combustion and blue for respiration. I'm going to use green for photosynthesis. You don't have to match my colors, doesn't matter. But I'm going to draw an arrow coming down to the plant. Carbon dioxide gets taken in by the plant during photosynthesis. And then what does photosynthesis produce? It produces oxygen. It also produces sugar, but this is the carbon-oxygen cycle, so we're just going to talk about carbon and oxygen. So photosynthesis takes in carbon dioxide, produces oxygen. Okay? And then we've got just one arrow going towards oxygen. If we only ever produced oxygen and didn't use any, that wouldn't be very good for us. That oxygen gets used up during, looking back at our equation, oxygen is used during respiration. So that oxygen comes down to the sheep or to you during respiration. Okay, I know that's a lot of arrows, so let's go over this one more time. To get carbon dioxide into the atmosphere, we can do that through combustion or through respiration. And remember, both plants and animals do cellular respiration, not just the animals. Plants do it too. So we've got respiration from plants and animals producing carbon dioxide. We've got combustion from human processes producing carbon dioxide. The only way we get carbon dioxide out of the atmosphere is through photosynthesis, which produces the oxygen that we then turn around and use for respiration. Okay? One more thing I wanted to mention here. So we talked about combustion. What are we combusting? We could be combusting wood from the trees. We could also be combusting fossil fuels, things like coal or gasoline. But where do those fossil fuels come from? So we have this little sheep over here, and eventually he's going to live a rich, full life, and he will be no more. And then the sheep is going to undergo decomposition. So all of the molecules that make up the sheep are going to break down, and you and the sheep and everything that's organic has a lot of carbon in it. And under the right conditions, with a lot of time and a lot of pressure, that carbon breaks down into coal or gas or other fossil fuels. Okay? Those fossil fuels get turned around and used to make energy to power machines and homes. So now that you've seen the carbon-oxygen cycle, what I want you to do next is answer these 4 questions in your notebook. Like I said before, everything that these questions ask is in the little clip that you just watched. So 2 processes that add carbon dioxide to the atmosphere, 1 process that removes carbon dioxide from the atmosphere. I want you to explain to me in complete sentences where fossil fuels come from, and then I want you to explain to me in 1 or 2 complete sentences how plants both add and remove carbon dioxide from the air. Now that we've taken care of the carbon-oxygen cycle, next one we're going to do is the water cycle. I believe you should have seen this before. I certainly hope that you have. So for the water cycle, what we're looking at is the way that water moves through our world. So it can be on the ground, it can be under the ground, it can be in the atmosphere, and we're going to talk about how it gets to all of those places. So we'll start with water that is already in the ocean. So the oceans are our largest body of water on the earth. That's where most of our water is stored. It's salt water, so it's not really drinkable or usable for people until it's been desalinated. It's had the salt taken out. But what it does, when that water in the ocean, it evaporates and goes up to the atmosphere. So evaporation is the first process. And this doesn't have to be just from the ocean. It could be from a lake, it could be from a river, it could be from a pond, it could be from any body of water will evaporate eventually. Another way that water gets up to the atmosphere is coming out of plants. So the leaves of plants transpire. They release water into the atmosphere. So we're going to label that transpiration. So evaporation and transpiration are two ways that our water gets up into the atmosphere. And once it's there, it undergoes a process called condensation. So those water molecules they link together to form clouds. When those clouds become dense enough, when they have enough water molecules that they are so dense they can't hold anymore, then they will come over here and they will start releasing that water in the form of rain or maybe snow, depending on how cold it is. And that, I think you know this word already, is precipitation. Okay, that's an N at the end. So we go from evaporation, coming out of the oceans or the lakes or the rivers, up to condensation, forming clouds. Once those clouds become dense enough, heavy enough, they drop that water in the form of rain or snow through precipitation. When that water hits the ground, it will run into lakes, rivers, and streams. Call that surface runoff. So that runoff will run maybe into a lake or maybe a river, but it can also go underground. So there are these underground pockets of water called aquifers. You might also hear the term groundwater. This is where we get a lot of our drinking water from. If you have a well near your house where you get your drinking water from, you're getting it from groundwater. And groundwater is really good because it doesn't evaporate, but it's also very easily polluted. So you do have to be careful about that and test your wells, test your groundwater before you drink any of that or use it. So that runoff runs into lakes. Those lakes drain into rivers. Those rivers eventually drain into the oceans. The cycle starts over again. It evaporates from the oceans or from the lakes and rivers. It goes up into the atmosphere. It condenses into clouds, and then it precipitates back to the ground, runs back into the water, does the whole cycle over again. This one's pretty straightforward. Just 3 questions about the water cycle to add to your notes based on what you just watched and heard. So the 3 questions I want you to answer are, where does the water go when it precipitates? Once it reaches the ground, where does that water go? There are a couple of different places it could go to. I want you to give me each one of those. How does water get into the atmosphere from the ground? And then the last question I want you to answer is, why does it rain? Each of those should be answered in at least one complete sentence, maybe more. Okay, The last cycle we're going to talk about today is the nitrogen cycle. The other two cycles that we've talked about have been fairly straightforward, maybe things that you've learned in previous classes. The nitrogen cycle is a little bit more involved, but it is very important to understand. As you remember from our chemistry units, nitrogen is an element. In most cases, it is found as a gas in our atmosphere. A majority of our atmosphere is actually made of nitrogen. It's important for people, animals, and plants because it is a major component in DNA, which is what makes you, you. Your body also uses it to form proteins and other important compounds that it needs. The problem with nitrogen is that the nitrogen that we find in our atmosphere, our atmospheric nitrogen, is not a kind of nitrogen that our bodies can use. It's not a kind of nitrogen that almost any living thing can use. Plants can't use atmospheric nitrogen to get what they need. We can't use atmospheric nitrogen to get what we need. So we need to change that atmospheric nitrogen, N2, into something else that our bodies can use. So there are several different forms, several different compounds that use nitrogen that we're going to talk about during this cycle. So we're going to start with our atmospheric nitrogen. It's the kind we find in the air. What we do with that atmospheric nitrogen, well, we don't do anything. What plants and bacteria do with that atmospheric nitrogen is they take it and they turn it into ammonia. And the way that we do that is we have legumes. So a legume is a specific type of plant, specific family of plants. It includes beans, peas, soybeans, chickpeas, that kind of thing. And what's interesting about legumes is that in their roots, the roots of these plants, they have these little nodules, these little round balls. And inside of those little nodules, they have these special bacteria that can fix nitrogen. And when we say fix nitrogen, what we're meaning is they can take this atmospheric nitrogen and they can turn it into ammonia by combining it with hydrogen. So on our cycle here, we're going to label the different processes that happen in the nitrogen cycle. First one we're going to label is that nitrogen fixation. So we're going to label that here. So nitrogen fixation happens when the bacteria that you find in the roots of these legumes change atmospheric nitrogen into ammonia. There's another way that you can fix nitrogen. So when we have lightning strikes, one of the things that actually happens when you have a lightning strike, that really high energy that you get from lightning strikes can also change atmospheric nitrogen into ammonia. So we're going to label that one as well. Nitrogen fixation. Okay, so two ways we get ammonia: from the bacteria that are found in the roots of legumes and from lightning strikes in the atmosphere. We get ammonia through those two ways. We can also make ammonia artificially through fertilizer. So humans can do this chemically through a process called the Haber-Bosch process. We actually add more ammonia to our atmosphere, not to our atmosphere, to our soil, because it helps our plants grow. That's what fertilizer does. In most cases, it adds ammonia to the soil. And that's good if you want your plants to grow bigger, stronger, faster, healthier. But if you add too much ammonia to your soil, and then it rains, and you get that water runoff with all that ammonia in there, you have a problem. So what happens when you get runoff with a lot of ammonia in it is you get this eutrophication. So what that actually means is you get lots of ammonia running into your ponds and your rivers, and the algae that live in those ponds and rivers love that ammonia. They love it so much that they grow really quickly. They cover the tops of those ponds, and they block out light and oxygen for everything else that lives in those ponds. And when you block light and oxygen, nothing else can survive. You get these dead zones. Alright, so once my bacteria has fixed my ammonia or my lightning or added it through fertilizer, what happens then, we can't use ammonia. Ammonia is toxic to people, it's toxic to a lot of plants, but you have other bacteria, these nitrifying bacteria, that change that ammonia into nitrates and nitrites. So nitrates and nitrites are something that plants and people can use. And that process of turning ammonia into nitrates and nitrites is called nitrification. So once that nitrification happens and the bacteria change that ammonia into nitrates and nitrites, these bacteria live in the soil, they've changed our ammonia into something that the plants can use. The plants take that in, they make proteins, they make their DNA. Consumers, like animals and people, go ahead and eat those plants. They also get those nitrogen-containing compounds. And this is what we use, these nitrates and nitrites. So once those plants die, or those people or animals die, they decompose. And our decomposers, our fungi or our bacteria, they can actually turn that turn those nitrates and nitrites back into ammonia, and they add it back to the soil. All right. What else we can do once we've made nitrates and nitrites? Some of it goes to feed plants and people. Some of it continues on and other bacteria get a hold of it. And once those other bacteria get a hold of it, these are different bacteria. They undergo a different process. And they change those nitrates and nitrites into atmospheric nitrogen, which is what we started with. So going all the way around our cycle, just around the outside of our cycle, we started with atmospheric nitrogen. We fixed it either through legumes, the bacteria that are in their roots, or through lightning, or through artificial ways with people. We turned it into ammonia. We nitrified it to make nitrates and nitrites. And then I forgot to label this part, but then we denitrified it. So denitrification is what happens here. We turn those nitrates and nitrites back into our atmospheric nitrogen. So just going around the outside, fixation makes ammonia. Ammonia nitrifies into nitrates and nitrites. Nitrates and nitrites denitrify back into atmospheric nitrogen. Okay, so those are our main processes. And then the nitrates and nitrites are what feed you and our plants. So last set of questions that go in your notes. For the nitrogen cycle, I want you to answer these 5. The first one I want you to answer is to name the 4 different forms of nitrogen found in the nitrogen cycle. 2 of those go together. For number 2, I want you to tell me, what does it mean to fix nitrogen? What is nitrogen fixation? What does it do? What are 4 things that can fix nitrogen? So 4 processes or 4 things that can do that. And then I want you to tell me what causes dead zones. And then finally, what's the name of the process? So the labeled arrow, what's the name of that one? That turns nitrates and nitrites back into atmospheric nitrogen. Once you've got all of these questions answered, you've got all of your diagrams drawn, double check your work, and then you can turn your notebook in to be checked. I am going to be checking these for a grade, so make sure that it is complete, that you were thorough, that you were neat, that everything that needs to be in there is in there, and that you've answered all your questions in complete sentences.